This chapter, I would just put it as chapter 6, okay? In order of our progress. Chapter 6, this is called electronic structure. And if you ask me, oh Sam, is it hard? Yes. Yes. Okay? So first of all, from chapter 2, what models have we learned? We learned Greek philosopher, Dalton, J.J. Thomson, Rutherford, right? And up to Rutherford, the model looked like this. Just saying, roughly speaking, there's a nucleus, right? He said there's a positively dense region in the middle, and most of the volume of the element is empty, right? So nucleus we have, an electron just flows around randomly like this. That was his model. Okay. Now the next guy, it's the next guy, is Bohr model. If I explain, like simply, okay? Bohr said, Bohr model looked like this. Just like planets around the sun. There's a nucleus in the middle. Electrons do not randomly move, but they move along something called energy level. We call it now principal energy levels, okay? 그러니까 이게 energy level 안쪽에서부터 1, 2, 3 electrons moves like orbits around the that's what he believed. Well, again, Bohr, the problem with the Bohr model was his model was only applicable to hydrogen. Why did it choose hydrogen? Because hydrogen has only one electron, right? This was simplest to analyze. Okay? 근데 was it all correct? Again, no. Okay? 근데 어쨌든, if some random guy says, what do you think about Bohr? What did he find? What's the most important aspect of his work? I would say he found out that electron moves along the principal energy level, okay? Energy levels. Okay? So yeah, so here, when electrons jumps from low to, when electrons go from low to high energy level, that's again, so think about it. When you're at the first floor, you want to go to a 5th floor, right? What do you do? Is it hard?
Yeah.
It's kind of tiresome, right? So you need to absorb energy to go from low to high. Yes? So that's the endothermic process again. Let's absorb energy. So only if you absorb the energy, this process becomes possible. If you go from high to low, energy is released. People often say in the form of photon. Well, don't pay too much attention to the word photon. It's the particle that has energy, okay? It is not neutron, it is not proton, it's the form of energy. Just keep that in mind, okay? And when this happens, there's something interesting. Okay, so how did scientists find all these elements? Any suggestion? Yes? Yeah. Go ahead.
Positive and negative charge. Using the positive and negative charge.
Using the positive and negative charge for?
Like when they used shot like the beam with positive beam or something, they found out that
nucleus.
Yeah.
Right.
And
that's Rutherford, right?
no.
자, 이거는 every element in that's how they were found, okay? Every element, when electrons in a given element, if you move them to a higher energy level, and then you let them go down to the lower energy, return to the lower energy level, something called visible spectrum is produced. Okay, visible spectrum. When you go from high to low, visible spectrum is produced. Okay. Yeah. So each element, say Na. I mean, this is not even close, but if I make a pattern, every Na will produce this pattern, this spectrum. If it's say Mg, it will say, just assume it will produce something like this. So every element has its own unique spectrum. Okay, that's how they found new elements. So for example, say someone walks in and say, oh Daniel, I found a new element, right? How do the scientists test that, that claim? Same thing, and then they run the spectrum, they obtain the spectrum and compare it with the existing spectrums, and then if it's really the new pattern, then it's new element. But if it's same pattern compared to what we had earlier, then it is not a new element. Does that make sense? Well, is that important? Maybe, maybe not. Okay, it depends on teachers. But all these, yes. Okay, all these, like low to high absorb, high to low energy is released. And Bohr said electrons move orbits around the nucleus and along the principal energy levels, right? And his model's problem was that it was only applicable to hydrogen. So far, so good? We good. Okay, now, guys, for real. 이거는 안 까먹기를 바래. For real. What identifies physical property of elements and its identity? Say identity of the element. What decides physical property? If it's sodium, if it's really the sodium, number of neutrons or mass number may change, right? And number of electrons may change as well, 2 plus 1, right? But how about number of protons? If it's sodium, it has to be 11 no matter what, right? So again, number of physical identity or property of given element is determined by number of protons, atomic number. How about chemical behavior? Why? Have I ever mentioned this? 여기 group 보면 we have 18 groups, right? 1 through 18. So we say if two elements are in the same group, they share certain similar properties. That makes sense. It was the group's other name was family, right? So that's because they behave similarly in terms of reactions and things, right? Have you ever thought about how they were grouped together? Very close, but okay, it's because of it's a 8th grade physical science. Number of valence electrons. Valence electrons decides chemical behavior. Okay, and what is valence? If you ask, it's the outermost located electrons. Okay, so for example, just a random element. Say we have 3 energy levels, and I have 2 electrons like this. How many valence electrons do we have? 2. Okay. So do you remember this thing, guys? For each group, for group 1A to 8A, I said the top ones. The charges were +1, +2. It's their common charges, right? Plus -4, -3, -2, -1, and so forth, 0. But the charge, no. The number of valence electrons are 1, 2, 3, 4, 5, 6, 7, 8. Always. Let me show you. Okay, let me show you. So now. So I said, you tell me, 태영이, take a look and look for nitrogen. How many valence electrons do you expect? Nitrogen. 5, according to this simple rule, right? Yes? 이거 잘 알아야 돼, 이거. 맞지? The quick rule is very useful. And 태균이, for calcium, Ca, How many valence electrons do you expect?
2.
2, right? And remember this, noble gases are called noble gas because it has 8 valence electrons. Every element, later on we'll learn, every element wants to have 8 valence electrons either by forming bond or by losing, gain, I don't care, okay? Their dream throughout their life is to have 8 valence electrons. Somehow.
1. Is it
That's the most stable form.
stable? Yeah.
Stables. It has to do something with the stability. So noble gases, they have 8. 8, and that's why they're called noble gas, right? Right? I mean, today's class is related to everything that we have learned so far, okay? So 이거 한번 볼게. Take a look. Please copy this properly as well. Can I erase?
Yeah.
Okay. So this is called diagonal rule, and I'm not going to erase it. And we said 5 valence electrons. Ca, we have 2 valence electrons. Let's check, okay? Let's double check. So do you remember that flow chart? The stoichiometry that I drew you guys, mass A, mass B, that thing. This is another thing that will be very useful, okay? 그럼 잘 카피해줘. 1, 2, 3, 4, 5 쓰고 2, 3, 4, 5 이런 식으로. 그 다음에 3, 4, 5. 그 다음에 4, 5, 5. 딱 칸 맞춰서 이렇게 그려주면 좋아. And then 오케이, 한 요까지만 해. 어차피 요거는 with the general chemistry that you're taking right now, it won't come out, okay? I guarantee. 요까지만 하면 돼. Okay, so first row is called S row. Second is P. This, I'll explain, don't worry. The third row is D, F, G. And S can hold up to, say, 2 electrons. This is 6 the pattern is +4 pattern. Okay? This can hold up to 10. This can hold up to 14. That's 18. Okay, just write this down and let me do it now. I'll give you time to write, but pay attention for next 3 minutes. Please. 내가 하나 보여줄게. For nitrogen, Haley, what's the atomic number? 7. How many? 야, 이거 틀리면 쌤 진짜 너무 실망할 것 같아요. How many electrons does it have?
Electrons?
Yeah.
7.
7. 7, right? Right, so we fill this in. So if you look at the periodic table, that's 14, 7, and that means we got 7 protons, 7 neutrons, 7 electrons. Yes? So let us apply this. It's called electronic structure or electron configuration. This is called, what I'm about to write is called electron configuration. Let's see. 7개까지 채우는 거야. Start with this, okay? That's the first thing, you see? That's 1s2, clear? Next one is 2s2, clear? Next one starts from p row. So that's 2p, how many should I put? 3, because we have 7 valence electrons. I mean 7 electrons, right? This is nitrogen's say electron configuration. And this proves nitrogen has 5 valence electrons. Why? These integers are that principal energy level, okay? 그러면 여기 딱 봐봐. 아까 쌤이 we have nucleus. We have 2 energy levels, right? 1 and 2. Energy level 1, energy level 2. 1에 2개. Energy level 2, we have 1, 2, 3, 4, 5. That's 5 electrons, right? In the outermost energy level, how many electrons do we have?
5.
That's why it's 5. That's why it's 5. So we say, for nitrogen, this is the electron configuration. Principal energy level is 2. In there, we have 5 valence electrons. Does that make sense? Clear? Okay, let me show you one more, calcium. So calcium, it has atomic number of 20, okay? Your job is just to follow the arrow, fill it up to 20 electrons. So let me show you. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Right? 이때 valence electron, 이때, no, principal energy level 얼마? Principal energy level. 태균이.
Isn't that
You're right, say it. 4. Highest integer.
highest?
Highest integer. That's 4. In there, how many do we have?
2.
That's when 이런 건 또 안 가르쳐 주는 거 있잖아, 쌤. 학교에서 알려줄게. So take a look. Take a look at nitrogen. What was his, for nitrogen we just did, what was his principal energy level? Which period is it in? Take a look. Which period? Period means horizontal row. period 몇 번 했어? 그러니까 인 거야. Quick rule. Okay, calcium, which period is it in? 4. Do we have principal energy level 4? Yes. Right? So what did I do today? I using the quick rule. Of course, 1, 2, 3, 2, 8 valence. So we could apply this and just quickly retrieve number of valence electrons, right? And the principal energy level using the period. But if your teacher wants electron configuration and say prove it or draw a diagram like this, you should do this. That's your only job. Anna? Can I let you try 2 questions?
Can you explain more?
Like,
About
so how, like,
Yeah.
how do you write that 1 as the,
you follow the arrow, so that's 1.
yeah,
Which row is it in?
first,
S row.
yeah, that's true.
Put S, right?
Yeah.
How many can it hold up to maximum? S는 2개까지. So that's 1S2.
Yeah.
얘는
2,
which row is it in?
that's
몇 개까지? 최대.
2,
2. What's the next one?
2,
2. Which row is it in?
P,
근데 우리가 it could hold up to maximum 6, but nitrogen has 7 electrons. That's already 4. That's why we put 3 here. The maximum is 6, yes, but you can't. Nitrogen only has 7 electrons in its neutral state.
and then P, what was,
Right.
the period, what was the P, what did P stand for?
P?
PE. The P,
Oh, principal energy level, highest energy,
highest,
highest circle,
and then,
outermost circle. Yeah.
and then the valence,
VE is valence electron.
the highest integers,
Number of electrons,
Yeah,
right?
number
So
of
in this case, again, highest energy is 2, principal energy level is 2. In there, we have 5 electrons, right?
Yeah.
So you can think of S&P something like this. So you guys all live in an apartment, right? 몇 호 할 때, the size may be different, but if you live in the second floor, you guys are all in second energy level, okay? Regardless of, say, size or the design, I don't know, interior, whatever. But 2 is 2. This stands for, say, something, 뭐, 구조나 그런 거. And it is, in fact, it is. S&P is different in structure. But that's AP Chem, don't worry, okay? Are we good?
Yeah.
Can I let you try? Can I erase these? Oh, did you copy all?
Yeah.
다 지워도 돼?
네.
Okay. 이거 조금 까다롭죠? 그때 한 것보다 조금. So, I1, hold on. 뭐 할까 나? 이거 하지 뭐. Bromine, that's 35. I1, its principal energy level and number of valence electrons. I mean, can I answer it right away?
Yeah.
Yes, principal energy level is equivalent to number of periods again. Valence electron, I said it's 7 for 17, right? But I'm not, as a practice, try these 2 questions by writing out the electron configuration. And one more, this ZN30, please, both. Same thing. Don't worry about PE for this one. I just want electron configuration to explain something.
Yeah.
Okay, here. 봐봐. 그냥 쌤은 알잖아, 스타일. 뭐, diagonal로서 just check the answer. 이거 뭐. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Right? 이렇게 나와야 돼. 그 다음에 C.
3D10 4D5
3D,
Uh-huh.
10, 4D.
I'm sorry. 3d10, 4p5.
4D5.
Right. And then this one is 이거 5개만 빼면 될 거 아니야. 그 끝에 1s2, 2s2, 2p6 we understand. 3s2, 3p6, 4s2, 3d10. Yes. So here, what's the principal energy level?
4.
Does it have 7 valence electrons? Is it proven? That's it. Right? Highest integer is 4. And there we have 7 valence electrons. Now, here, why did I tell you to do this? There's a 그냥 심심해서 하라는 건 아니고. Yeah.
B가 2인데
Right?
but it's not in the second.
D가 2인데. No, that's principal energy level. Principal energy level.
That's,
Is it in 4th or 3?
It's 4.
it's 4.
Right, so its principal energy level is 4. Right.
Yeah.
So there's something that I want to explain. So here's for past 20 years, this question came out twice. Where? AP Chem FRQ. FRQ. Is it hard? No. Okay? 한번 보여줄게. If you say your elements wants to fill this as much as possible, okay? As much as possible. If you were to take out 2 electrons, right? 2 electrons, would it be, 여기 딱 봤을 때, one might just say, you take out electrons from the end, normally. So one might expect it should be, 앞에는 똑같고, 4s2, 3d8. No. No, this is not the answer. What is it then? This has to be, if you're taking out 2 electrons, 3s2, 3p6, 3d10. You have to get rid of 4s2. Why? All other orbitals are filled. That's better for what? Stability. Right? So what am I trying to say? 4s and 3d are very, very close in terms of energy level. The order may get switched depending on stability. 4s and 3d, okay? Right. Are we clear? So now, I'm going to explain one more thing and we'll take a break. So guys, take a look. Take a look. This is very interesting. No joke. So you guys understand here, the principal energy level is 4. Number of valence electron is 7, right? How many valence electrons do element 1? How many?
7.
Oh, mobile gas, how many?
Wow.
8. That's their dream, right?
8.
그러면 얘가 한 개 더 얻으려면 한 개 더 얻어야 되잖아. When you gain 1 electron, what's the charge? Oxidation state. When you gain 1. 수학이랑 반대로. What is it?
Minus.
What's its charge, BR? Can you take a look? 그래서 BR minus 1인 거야. That's his primary charge because he only needs one more. He likes that charge. He loves that charge the most. Let me show you one more thing here. Sodium is 11, right? 1s2, 2s2, 2p6, 3s1. Now, currently, in a neutral state, how many, what's this guy's principal energy? Pigmini.
That's
3. Valence electron?
1.
1, right? But if you want to have 8, when you get rid of this, how many valence electrons do we have right now? What is its principal energy level?
2.
How many valence electron?
8.
What's its charge? Plus 1. Chem is all related. God damn it, right? It's all related. Yeah? And some other fun part about the chem is, it's not really fun, but it is fun to me. There are a lot of exceptions, like what? 4s and 3d. We normally remove the electrons from outermost orbitals to inner one. But 4s and 3d, that's exception. Depending on stability, again, order may get switched. Yes? There's something called orbital configuration. Okay, orbital configuration. Let us take a look. So that's 1s2. Remember that SPDFG, S can hold up to 2, P can hold up to 6, D10, F14, G18, right? Maximum number of electrons where we call this sublevel. Integers were principal energy level, right? These are called sublevels. Okay? So maximum number of electrons are these. And then, please remember this. 이거 짝대기 하나가 one orbital이야, one orbital. Okay? What's the pattern? Plus 2 pattern. Right, it's a plus 2 pattern. Number of electrons plus 4 pattern. Okay? So let me show you, using a simple example. For fluorine, let me write out the electron configuration real fast. Okay, so 1s2, 2s2, 2p6, 3s2, 3p. What am I saying, man? 2p5, right? So principal energy level is 2. We got 7 valence electrons. Every element wants to have 8. Its primary charge must be -1. And it wants to gain electron, right? Now, orbital 그려면 S has one orbital, right? So 1s, 2s, and 2p. Right? So when you fill this out, one orbital can hold up to 2 electrons. So we call this a spin. It's up, down, and be careful here. When you fill these in, it has to be as follows. Up, 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 and then down, down. What do we call this? Hund's rule. Hun said, Hund's rule. Is it important? Yes. Hun said, when you fill out this orbital configuration, you want to avoid electron repulsion as much as possible. 왜 이렇게 콩콩거려? Right? So how about this? So fully filled가 제일 stable하다 그랬잖아. 그 다음 stable한 게 half filled야, half filled. Let me explain why. So this example is nitrogen. Nitrogen, it has 7 electrons. It's 1s2, 2s2, 2p3. Orbital configuration, 1s up down, 2s up down. 2p, it's up, up, up. If it's possible, you want to avoid the electron repulsion as much as possible. So now, the second reason, it's related to the first reason, but because half filled is next stable to the fully filled, we go this way. What law is this or rule? Hund's rule, right? And I think here, each principal energy level, the number of maximum electrons that each principal energy level can hold is defined by 2n squared. So think about it. Energy level 1, right? How many electrons can it hold? Only 2. 2n squared is 2, right? Energy level 2, that can hold up to 8. So 2n squared, that's 8, right? That's okay. And lastly, here. Can I erase everything? Alright. It is Lewis dot diagram. So for Lewis dot diagram, why is it important? We use this diagram to draw bond structure later on, maybe Thursday or Friday. But just for now, we'll do it for some elements. Okay, this is how you draw. Each side can hold up to two dots. Okay, calcium. How many valence electrons does it have? Calcium, right away. Oh, that's first one level, 2, right? So you draw 2 dots like this, or doesn't matter which side, just draw 2. Okay, that's called Lewis dot diagram. And say for nitrogen, how many does it have? 5. 1, 2, 3, 4, 5. Right?
Yeah.
Side doesn't matter again.
You just draw around, like just draw the dots around it.
Yeah. Each side can hold up to 2 though.
Oh, okay.
Right. Yes, are we clear?
Yeah.
That's the end of chapter 6. How many did we finish? 6. Okay. Let's do one more short chapter.